Hello, everyone. So we're gonna do 4.6 directional derivative and gradient. So previously we do partial derivative respect to x. Then that is x direction, right? Partial derivative respect to y, then y direction. So we want to find the slope parallel with x-axis. That's x direction. We want to find the slope and parallel to y direction, y-axis, then that's the y direction, right? That's why we treat y as a constant when you make a partial derivative with respect to x, right? And then we make x as a constant when you make a partial derivative with respect to y, right? Okay, now what if we have another direction? So basically, we want to find the slope any other direction, right? Beside the x direction, beside the y direction, right? So we have directional derivative. So we want to find any direction of, so we have the curve in 3 dimension, right? So, yeah. So this is x direction, find the slope of a tangent line. Find the slope of a tangent line of y direction, right? What if we have this direction, or what if we have this direction, this direction, this direction, this direction, right? So that is the directional derivative. Make sense? Okay. Now we have another terminology here. So gradient. So this is a fancy word of slope. So we're gonna find the slope. So what kind of slope is this? This is also slope, right? So this one, we want to find slope of tangent line of the function, right? And this one, slope of a tangent line of vector valued function. So vector value ij, right? Okay, this is just a function. Equation g equal to f of x, y equal to the function. All right. Okay, let's do it. We have a learning objective. Okay, so how do you find the partial derivative with respect to x? So we have the formula, and then we have a partial derivative with respect to y. We have a formula. Okay, so that is the last section we talked. This section is about the directional derivative. So which direction we want to find of derivative? So we have the formula. We know that this is a unit vector, right? Okay, then we have cosine theta I hat plus sine theta j hat. So we want to follow this direction, u direction, all right? So u direction, which is cosine theta I hat, sine theta j hat. Yeah, okay. So we denote notation like this. D sub u hat and f of AB, this notation, then directional derivative. Okay, then this is the formula when the limit exists, right? Okay, let's find out the directional derivative. So we have this example, theta equal to arc cosine 3 over 5. Find the directional derivative. And then the function is that. So we want to same direction of u. We need to find. So when xy equal to -1 and 2. So finding the slope at with this direction at -1 and 2. Make sense? Okay, so we are going to use this formula, which is given. So since we have xy, I change the AB as xy. So everything will be same. All right? Okay, this means we substitute into this one x, this one into y. All right? Okay, let's write down. So that will be equal to limit exists when h approaches to 0. So this one into the x squared. So we have x plus h cosine theta squared minus x plus h cosine theta y, which is y plus h sine theta plus 3y squared. So that will be 3, this one squared, right? So 3y plus h sine theta squared all over h, right? Oh, minus of that, right? So minus, then copy everything, this one. So let me just make a copy and paste. All over h. Yeah. So you guys okay with this? Because, sorry, itching. All right. So we have x squared. So we did that, right? And the xy, x, y plus 3y squared. And then minus x, f of xy, just copy here. Now, all over h, yeah? So rewriting. Okay, so let's do algebra. So this one, sum of squared, right? So we are using that. So equal to limit h approach to 0, x squared plus 2xh cosine theta, right? Plus h squared cosine squared theta, right? Please correct me if I make a mistake. Minus, be careful, we have a negative, right? So, ooh. Okay, so distribute, yeah, but we have a negative. Let me slow down. So negative xy, distribute, but we have a negative, so negative x h sine theta, right? Okay, now second term, distribute, but we have a negative, so yh cosine theta. Okay, last term, h cosine theta sine theta. So h square cosine theta sine theta, right? So with a negative, h square cosine theta sine theta. Okay, so that is the second term. Now, third term, once again, we have sum of squared, but we have a positive 3 in front. So let's do together. So y squared times the 3, so 3y squared. Then 2ab, so 2y h sine theta. And then we have a 3 there, so 6y h sine theta, right? Plus last term square, so h squared sine square theta would times 3, right? So 3h squared sine squared theta. Yeah. Okay. The last term, we just distribute all the sign. So we get negative x squared plus xy minus 3y squared. Yeah. Okay. So all over h, right? Sorry about that. Okay, now let's simplify x squared, negative xy, positive xy, then 3y squared, negative y squared. Okay, anything else? Let's make ice bigger. Okay, then we have experience. Let's skip the one step. Let's take factor out with h because h is common there. Yeah. So that we can simplify with h, right? That's the technique. We've been doing that. Okay, h and 2x cosine theta plus h cosine square theta minus x sine theta minus y cosine theta. That's the top row, right? Second row minus h cosine theta sine theta plus 6y sine theta plus 3h sine square theta. That's the second row. Yeah. All over, because the third row is all simplified, right? Okay. Now, we can simplify h over h. So then we have limit h approach to 0. So we have 2x cosine theta plus h cosine. I need to write down everything. Square theta minus x sine theta minus y cosine theta. Man, I cannot write down in one row, so I'm gonna just copy them. Copy, paste. Yeah. So we don't have a fraction. This is just one line, right? Okay. So then we can apply the limit when h approaches to 0. Then look, this is equal to 0. This is equal to 0. This is equal to 0. Then we have equal to 2x and cosine theta minus x sine theta minus y cosine theta. and plus 6y sine theta. Done, right? Okay, so what is cosine theta, sine theta? So it's given we had r cosine 3/5 equal to theta, right? So let's copy that. Copy. So we have, yeah. Okay, then if we make cosine theta, yeah, because this is inverse of cosine, right? So we switch over. So there will be cosine theta equal to 3/5, right? Okay, then how do you find the sine theta, right? So cosine theta, which is, let's think about that. In terms of right triangle, Jason over hypotenuse, right? So there will be Jason over hypotenuse. Let's denote it this way. So there will be in the right triangle. So angle theta is there. So Jason is 3, hypotenuse is 5. Then what is the side then? This side. So this is a nice number, 3, 4, 5, right? So if we don't know how to find, maybe we can find by Pythagorean identity, yeah? So a squared, you can find, right? Plus b squared equal to c squared. So we can find b, which is 4, right? Okay. Then what's the sine theta? Sine theta, which is opposite over hypotenuse. So my all the trigonometry, the previous students, they always say SOHCAHTOA, SOHCAHTOA, right? So okay, opposite. So opposite side is 4 and hypotenuse is 5, right? Okay, then we can conclude. So that will be, oh, let me just write down this way. Make just this way, yeah? So equal to 2x and cosine theta, which is 3/5. Cosine, yeah. So how about that? And minus x sine theta, which is 4/5. And minus y cosine theta, 3/5. And plus 6y sine theta, which is 4/5, right? So if we simplify, then the first one we get 6x/5. And second term we have 4x/5. Third term we have 3y/5. And plus 24y/5, right? Let's combine like term. So we get the first two term is 2x/5. And then last two term we get positive 21y. y over 5, right? Okay, so we're not done yet. Oh, hold on one second. So we want to find the directional derivative when x equal to -1 and 2, right? So we want to know directional derivative when x equal to -1 and 2. So we have 2x over 5. Let me make this one. xy first. And plus 21y over 5. So when x equal to -1, y equal to 2, equal to, we have 2, -1 over 5 plus 21, y equal to 2 over 5. Can you please calculate? So we get 8, yeah? Okay, so this means the slope is 8 at the point -1 and 2. But we say that this is directional derivative. Which direction? So this direction, nu. So let me write down first. So this means slope is 8 at -1 and 2. Therefore, xy in direction of u. So u equal to cosine theta, right? Cosine theta I direction plus sine theta j direction. That is a formula we are given, right? So in that case, cosine is 3 over 5 and sine is 4 over 5. We just found earlier, right? So that is 3 over 5 I hat plus 4 over 5 j hat. Okay, so let me show you the picture. Okay, so I brought the picture here. So if we substitute the -1 and 2 into the function, we get the 15. That's a z coordinate. So they have a -1 to 15, this point. And then we want to find direction, right? So the direction is you hat, which is 3 over I hat plus 4 over 5 j hat. So that is approximately 0.6 I hat. So from here, go to the 0.6. Yeah, and then that's the I direction. And then 0.8. So from here, and then approximately 0.8 going to here. So I made the arrow here. That is direction of u. All right? Can you see that? Then the red one, they just extend. This is the same direction. That's why. Make sense to you? Okay, now we have a theorem 4.12 directional derivative of function of two variables. So we are using formula of limit, right? So every time when we talk about the slope of a tangent line, we always express the limit, right? So always using that. After that, oh, limit is too much work, right? then we have the formula how to derivative, right? So we are following partial derivative here. Okay. Look, partial derivative with respect to x again, partial derivative with respect to y again. Huh. But then we are following this direction. Yeah, u direction. All right. Even though we have partial derivative with respect to x, partial derivative with respect to y, we're not following their direction, right? We're following this direction. Okay. Okay. Now we have the equation. We have the example. So we have equation there. We want to find the directional derivative of this equation with the following this direction. You have cosine pi over 3 I hat and sine pi over 3 j hat. So what's the cosine pi over 3? It's 1/2. What is the sine pi over 3? It's the square root of 3 over 2, right? So we have that. Okay, so we want to know about when xy is 3 and 4. We want to know about the directional derivative at 3 and 4, right? With the direction of u hat equal to 1/2 I hat plus square root of 3 over 2 j hat, right? Okay, now then we are using this formula. Okay. All right, then partial derivative with respect to x. So let's do that. We're looking at this equation, partial derivative with respect to x. That means we treat the y as a constant, so we keep the y, 3y, and the derivative x squared, which is dropped to 2, so 6yx, yeah? 6xy, cosine theta, in that case, cosine pi over 3 plus, oh, second term. Second term. Second term has, this is a constant, so we keep the constant. So negative 4y to the third power. Yeah. And then this is 0, y is constant, and then negative 4 then, right? Okay, so partial derivative with respect to x with a cosine pi over 3. Okay, let's move on to second term, which is partial derivative with respect to y. Screw up. Well, okay, let me arrange it a little bit. Negative 4 pi missing. That's it, right? Okay, second term we have plus x is constant, so we keep the 3x squared and partial derivative with respect to y, so negative 12x, right? Y squared, yes, good. And then 6y. Then the next one is 0. Okay, then sine pi over 3. Yeah. So this one. All right. Let's substitute, basically evaluate when 3 and 4. So directional derivative of u, f over 3, 4. So 6, 3 times 4 minus 4, y to the third, minus 4. Okay, cosine pi over 3, we had earlier 1/2 plus 3 x squared, so 3 squared plus minus 12 x 3 y squared 4 squared plus 6y, sorry, no space, y, and messy, and sine pi over 3, which is square root of 3 over 2. Okay. Very messy. So this term, the first term, we get negative 188, 1/2, plus second term, we have negative 525. Really? Then we have a square root of 3 over 2. Can you please calculate? So that would be negative 548.66. This is a slope, right? Slope. And which direction? So with this direction, which is, what was it? Cosine pi over 3, which is 1/2 direction, 1/2 I direction plus square root of 3 over 2 j direction, right? Okay, so you guys okay with this? All right, so we finished directional derivative. Let's do gradient. Okay, so we have a gradient here. So we talk about the partial derivative with the function, right? So three-dimension function. Or the earlier section, we talk about four-dimensional function too, right? Okay, now we have a gradient, which is a fancy word for the slope, right? So this is also partial derivative because we have a more than one variable, x. That's why with a partial derivative, right? X, Y, Z, or W. But then in that case, we have a vector valued function. All right. So in Greek letter, we have the symbol. So like a triangle symbol, we have a delta, and then this is uppercase of Greek letter. Okay. So little triangle. And then we have also this letter, we have lowercase delta, all right? So this is the uppercase of delta, lowercase of delta. And then we have upside down triangle. So this is a triangle. This I'm brought to this one. And then this is upside down triangle. So this symbol we using, we called nabla, right? And then we read del f. What this means, this is a gradient of f. We're using that, okay? All right, so we can read del f or gradient of f of xy, yeah? Okay, so we have the formula, partial derivative, right? So just definition is partial derivative of vector valued function. So we have a partial derivative vector valued function, right? So easily to remember, gradient, right? Because we just follow the definition as the formula, right? Okay, so make sense? All right, then let's do example. So we have example here. So find the gradient and then symbol. And then we have equation function there, right? Okay. Okay, so let's do this one. So we make a partial derivative and the vector function, right? All right. So equal to partial derivative with respect to x. So that will be 2x and minus second term, which is y, right? And third term is 0. And then we make a vector valued function. That's the formula, right? All right. So that will be I hat plus partial derivative with respect to y. So this is 0. And x is a constant, so negative x. And 6x, I'm sorry, 6y, right? So I said the negative x. Well, negative x plus 6y. Let's make a positive there. Positive, negative, and j hat, right? So we make a vector valued function with a partial derivative gradient. It's the same slope, right? Okay, so we have one more. Second one, f of x, y equal to sine 3x cosine 3y. Okay, so let's find this question gradient. So we have a sine 3x cosine 3y. So gradient f of x and y equal to partial derivative with respect to x. So sine 3x, and then cosine 3y is the constant, right? So derivative of sine is cosine 3x, right? But we have a chain rule. And then this is constant, right? Make sense? Let me read. You might a little bit confused. So 3 cosine 3x, yeah? And the cosine 3y is constant. Yeah. So we have a chain rule. Okay. That's for partial derivative with respect to x. I had. Then partial derivative with respect to y. So that will be derivative of cosine, which is negative 3y, and then chain rule, so derivative of 3y, which is 3, right? So we have a negative 3 cosine y, and sine 3x is constant, we keep that, right? So we have positive negative 3 cosine, I'm sorry, negative sine. Derivative of cosine is sine, right? Negative sine, so negative sine 3y, and constant, we keep the constant. So sine 3x, yeah? J. So let me write down cosine 3x and negative 3 sine 3x, 3y, 3y. And sine 3x is constant, right? So that's it. Yeah. Okay, so we have properties of gradient. Okay, so we have properties of a gradient. So the gradient equal to 0 vector, then directional derivative also is 0, not also, is 0. And the gradient is not equal to 0 vector. The maximum value of directional vector is the magnitude of gradient, right? So they say that when the unit vector points in the same direction of the gradient, all right? And minimum value, then it's the same as directional vector of u, and then we have a negative in front of magnitude of a gradient, right? In that case, when the unit vector points in the opposite direction from the gradient, all right? Okay, so let's make a notation. So we know that unit vector always followed by the vectors, right? So unit vector follow this vector v. So this unit vector followed by this r vector, and this unit vector followed by the gradient. Yeah, so just follow that concept, right? So how do you find what's the formula for unit vector? Then we are using vector v divided by magnitude of vector v, right? So how do you find unit vector in gradient? Then the gradient of f divided by gradient, magnitude of gradient, yeah? Okay, so we have this question. So we need to find direction of a directional derivative, this equation, and then there is maximum. Yeah. If there is maximum, what is the maximum value, right? Then number two say that we can find the maximum value, same directional derivative of u of the function, the magnitude of gradient, right? Okay, so in that case, magnitude of gradient when negative 2 and 3, right? Okay, let's do it. All right, so we needed to find out the gradient first, then partial derivative with respect to x with a vector I hat, and partial derivative with respect to y, j hat. Oh, sorry. I did not erase. Hold on 1 second. Okay, so let's do this one. Partial derivative with respect to x. Let's take a look at this function. Okay, so 6x minus 4y, right? So 6x minus 4y. I had plus partial derivative with respect to y. So negative 4 y. So negative 4x plus 4y, right? Negative 4x minus 4 positive 4y j hat, right? Okay, so we want to know about gradient when x equal to negative 2 and 3. So it's using that. So 6 negative 2 minus 4 positive 3 I have plus negative 4 negative 2 plus 4 y 3 j hat, right? Okay, so what do you get? Negative 24 I had plus 20 j hat, right? Okay. Let's find out unit vector for the gradient, right? Okay, then I said that earlier, right? So this formula we're using it. All right, so in the case, negative 2, 3, right? And then negative 2, 3. All right. So that would be negative 24 I hat plus 20 j hat over magnitude of that, so square root of negative 24 squared plus 20 squared, right? Okay, so that would be negative 24 I hat plus 20 j hat over square root of 976 equal to I have plus 20 j hat over simplify for square root of 61. Okay, then we can simplify for negative 6i plus 5 over 4 square root of 61, which is negative 6i plus 5j over square root of 61. Yeah, okay. We had earlier the unit vector corresponding cosine theta plus sine theta, right? So let's make it this way. Negative 6 square root of 61 I had plus 5 over square root of 61 j had. Then we have u hat equal to cosine theta I had plus sine theta j hat, right? So corresponding this, right? Okay, then there will be negative 6 square root of 61 I hat plus 5 over square root of 61 J hat, right? All right, then they say the maximum value. So that direction, which is U hat, which is negative 6 over square root of 61 I hat plus 5 square root of 61 J hat from this point, right? And then the maximum value will be the magnitude of that. So magnitude of that is square root of 61. Oh, square 4 because we simplify, right? So maximum is maximum value is magnitude of the gradient in the point negative 2 and 3. So it's 4 square root of 61. Okay, so here's a nice picture. There's maximum value, right? Okay, so we have a theorem 4.14. The gradient is normal to the level curve. All right, so we talked about the level curve before. So graph over level curve, we say the contour map, right? What is the normal? So normal means orthogonal, right? Okay, so we have partial derivative and the gradient is not equal to 0 vector, then the gradient is normal to the level curve of the function of the point. Okay, let's talk about this one more time. So recall tangent vector. So if we have a vector of R, then we have this component because this component from cosine pi over 6 and sine pi over 6, right? But then we had a derivative and then we say that this is a tangent vector, right? Tangent vector. All right, then can you see that it's a change component? So reversing component with times -1, right? Okay, so we went over this one before. Now, when we find the tangent vector, so if we have a component, we just reversing and then multiply by -1, all right? Okay, let's do this example. So we have the function. Now we want to find the tangent vector to the level curve at point -2 and 1. So looking at the tangent vector is normal to the vector, right? So we are using this. So basically we want to find the gradient, all right? Because this is normal to the level curve, yeah? Okay. Let's find out. So gradient of f, then we get the partial derivative with respect to x. I had vector valued function and partial derivative y and j, right? Okay, so that will be partial derivative with respect to x. We have a 4x minus a 3y, 0 and plus 2. You guys okay with this? Okay, so then that is I hat plus partial derivative with respect to y. So we have a negative 3x and plus 16y and minus 4. Yeah, j hat, right? Okay, now we want to find when negative 2 and 1, right? So that will be negative 2, 1. So that would be 4 times negative 2 minus 3y, which is positive 1, plus 2 I had plus negative 3, negative 2 plus 16. Y, which is 1 minus 4, j hat. Okay, can you please calculate? So we get negative 9 I hat plus 18 j hat. So that is not zero vector, right? Okay, so tangent vector we can find reversing the component and times with 1, right? All right, so that would be negative 18 I hat minus 9 j hat. Yeah. So we can conclude this gradient at negative 2 and 1 is normal to the level curve. Moreover, it's a tangent vector. Okay, we have a picture of that. Let's take a look. So this is a gradient. So there is negative 9 I hat plus 18 j hat, right? So this is a tangent vector from hold on 1 second. Yeah, so this is gradient when x equal to negative 2 and 1. So that is negative 9 I hat plus 18 j hat, right? Okay, then we have normal, which is tangent vector, right? So this is tangent vector. So gradient is normal to the level curve. This is a level curve. Then also tangent vector is normal to the gradient, right? Okay, so you can see that here. All right, so I made a note here. So the normal vector is marked. The gradient and perpendicular, the tangent vector. So if we make a dot product, then it's zero, right? So right here, make it a little bit bigger. So 0. Okay, so we have a three-dimensional gradient and directional derivative. Okay, so first of all, the gradients first. So we can just add one more variable. That's it. So partial derivative with respect to x, I had partial derivative with respect to y, j had partial derivative with respect to k had, right? Okay, so let's do example. We want to find the gradient of this function. Then we can just using this formula. Copy that. So partial derivative with respect to x, then we have 10x minus 2y and 0, 0, 0 plus 3z then. Yeah? Okay. Now, partial derivative with respect to, this I had partial derivative with respect to y. That is plus negative 2x plus 2y minus 4z. That's it? Yeah. J hat. And partial derivative with respect to z. That is z. Negative 4y, right? Negative 4y plus 2z and plus 3x. So let me write down plus. Let's using that. Plus k hat negative 4y plus 2z plus 3x k hat, right? That's it. All right. Now, let's do how to find the gradient. Okay, so we have a theorem 4.15 directional derivative of three variables. So look, if we have two variables, the vector u, unit vector has cosine theta I hat plus sine theta j hat, right? Okay, then we have more variables, so we don't know which theta using it, right? So look, instead of a sine, right? So we are using cosine alpha, cosine beta, cosine gamma. Can you see that? Can you compare with this? Okay, then in two variables, we get directional derivative, which is a partial derivative with respect to x cosine theta, right? Partial derivative with respect to y sine theta. How did we get this one? Because we have a partial derivative. So basically partial derivative means the gradient dot product of unit vector u, right? Then we get this one. Make sense? So that is partial derivative with respect to x cosine theta plus partial derivative y sine theta. Can you see that? So does it here. So gradient dot product with unit vector u. So u is the in terms of angle, right? So instead of that, we are using cosine alpha, cosine beta, cosine gamma, right? So we make a dot product Then when you make a dot product, we are using just component, no vector, right? So if we have that, then we get this one. So partial derivative with respect to x cosine alpha plus partial derivative with respect to y cosine beta plus partial derivative z cosine gamma. All right. So let's do this one. All right. So we want to apply this formula, but then we had the partial derivative with respect to x, y, z from the earlier, right? So let's using that. So we have this one. This is the last question. So please hang in there, copy. So there is, this is the gradient, right? X, Y, Z. Okay, now, maybe we want to find, evaluate, basically. Can we evaluate to first? So, F, 1, -2, 3, right? So there will be 10 times x1 minus 2 y -2 plus 3z, which is 3 I have plus -2x 1 plus 2 -2 and minus 4 z, which is 3, then j hat, okay, plus -4y -2 plus 2z, which is 3, plus 3x, which is 1, k hat. All right, so we get, there will be 23 I had, minus 18 j hat plus k. Oh, what did you get? 17? Okay, now, we want to know about the cosine alpha, cosine beta, cosine gamma, right? So we have a, you had equal to that, right? But then we don't have any information here, right? So we have information about only vector u, then look, we have a unit vector, right? So note. So we have a unit vector, you have, which is equal to same as vector v over magnitude of vector v, right? So then we have a vector v, which is, we can use a vector notation over square root -1 square plus 2 square plus 2 square, right? Okay, then we get -1, 2, 2 over square root of 9. That will be, let's do this way, -1 over 3 I hat plus 2 over 3 j hat plus 2 over 3 k hat, right? Okay, so that will be corresponding because it's the same nu, right? So that is corresponding cosine alpha I have plus cosine using different color. So that is cosine alpha plus cosine beta and plus cosine gamma, right? So once again, let's apply this formula. Copy. This one. All right, so we have directional vector, directional vector of u of f of what was it? Positive 1, negative 2, 3, right? So positive 1, negative 2, 3 equal to the partial derivative with respect to x when 1, negative 2, 3. So we have a 23. And then cosine alpha corresponding that, right? So negative 1/3, 1/3, yeah, plus 23 and negative 18. I'm using the on the top, and then cosine beta corresponding to third, and plus 17k, so 17 cosine gamma corresponding to third. Yeah. Can you please calculate this one? What do you get? So this is negative 20 over 5. So this is a slope. And at negative 1, negative 2, slope. At 1, negative 2, 3. With the direction you had. So this direction, negative 1/3 I had plus 2/3 J hat plus 2/3 K hat. All right. Okay. Thank you so much for watching. I will see you in the next video. Thank you. Bye.